Pervious concrete is a rigid pavement, is a highly durable product, has a long track record with its use. I think it's probably had the longest track record down in Florida. When I worked on my first pervious concrete project in Bellingham back in 2001, all of the specifications and information that we used for that project came out of Florida, but now we have a thriving pervious concrete industry here locally. Integral color is available, so it can be either a kind of traditional concrete gray, or all of the integral color systems will work. I've had some projects that we've used some integral color to match the architecture and so forth, and we're usually coming in around over 15% voids. So there's a little image there of what I think is really maybe first generation pervious concrete in this area. Had a little bit of a coarser aggregate. It was bigger than the 3/8 or so. Maybe it was almost 3/8 to ½ inch, maybe. And I think the more successful, more recent applications have a finer aggregate, more like a 3/8 to #4, more something around a kind of a poorly graded quarter-inch pea gravel mix, if it's available, is what we've used. And Curtis is going to run and grab a couple of samples that we have that we'll pass around that'll show the different gradations. In essence, this is a typical section there from a project of mine. We typically have no fine aggregate, no sand in this mix at all. Sometimes it's called a no fines concrete mix. However, sometimes a few percent of sand is necessary if we have too many voids. If we have if our open graded coarse aggregate that we're using for our pavement has got too many voids, we sometimes need to throw, again, like 1 to 2% sand in there just to bulk up that paste and make sure that we've got good paste coverage and interlock between the aggregate particles. There is a series of admixtures that are typically provided. Viscosity modifying admixture, VMA, is very often used. There are some emerging admixtures, particularly around curing, that are coming. In the samples that are going to be coming around, the smaller hockey puck is the current design. It's I call it the kind of shopping cart friendly mix design. I think it's got a pretty acceptable smoothness, high heel friendly, and so forth. And the larger disc is a slightly older design of mine, but more traditional. It's something you'll still see around, but it's a little bigger, more like a 3/8 aggregate. So in terms of the aggregate, we can live with a 67, but we're really wanting to shoot for like an ASTM 7 or even a number 8 if it's available. That's really the direction that we want to go, but it's always a balance, the interplay between the aggregate and the particular mix design. They kind of need to work together so that we can maintain our porosity, get good bond strength. And then we very often have monofilament fibers in there as well to kind of increase our strength. I typically do not use choker courses, again, like some of the issues that Mark mentioned. If we've got good fracture faces, and every time I've done it, we've been able to build right off of the reservoir course. In pedestrian areas, we can consider using like a 57 stone or something that's, although it doesn't have the fracture face requirement, so it tends to be subject a little bit to rutting, so you might need to augment that spec with a requirement for fracture face if you want to use it. But the note here, these 3 additional base options for pedestrian areas are mostly related to the fact that it's just a smaller aggregate size, so which can deal with potentially a smaller base. But other than that, they're all doing the same thing, which is that they're providing good structural support as well as good void content. The permeable ballast is really the kind of the go-to base rock reservoir course that is more often available. So some of the really important things that have happened in the pervious concrete world is 2 things. One's on this slide, which is ACI 522. ACI 522 is the pervious concrete specification from ACI. It is somewhat focused on certain areas. I encourage you to spend some time with it as you're developing your own specifications, to really look at 522 and understand where you really want to refer to ACI 522 entirely, or maybe you want to augment 522, come up with a specification that is going to work for you. But ACI 522 really is designed to be a standalone spec with very little additions, but in the advanced class, we'll probably go into some great detail on kind of areas where some jurisdictions and designers often feel the need to augment 522. The other big note is around ASTM specification. So this is another really important one that many of the absolute standard ASTM tests for concrete do not apply pervious. They don't work and they're not appropriate. And that was learned certainly by some of us early adopters the hard way. But, for example, we don't use compressive strength as a measure of verification like you would on a normal concrete project where we'd be casting cylinders and doing break tests because basically we cannot create the cylinders in a representative way as is in the pavement. So typical ASTM cylinder procedure has you rodding the material, and of course that it gives you overly unrepresentatively dense material. So, and similar for the beam tests. Early on one of my first big pervious projects about 10 years ago, I really wanted to verify that my modulus of rupture was what I used in my calcs. And so I spent a bunch of money casting flexural beam tests and doing breaks. And we learned also that it was just a huge scatter of not useful data. So the verification process that we use other factors. The other significant development, maybe in the last 5 or 8 years, has been the arrival of the National Ready Mix Concrete Association contractor certification process, which as a designer is probably the more significant development is the education of the installers, because the product's not particularly difficult to work with, but it's sufficiently different enough that requiring your contractors to be certified is an absolute must and a minimum. And there's sets of criteria. There's 3 levels of certifications. You have the craftsman, the installer, and the technician. There's a training, and then to get to craftsman level requires a bunch of practice in the field. And so what I do in my projects is, depending on the size of the project, I require in the specs a certain number of technicians, a certain number, at least 1 craftsman, certain numbers of installers, and I have a little process in the specs where at increments of increasing 5,000 square feet of material, you kind of add technicians so that you can really have a full crew, so that everybody on the crew understands how the product works, and then to require that the craftsman be actually a part of the working crew and not just a paid observer, so that you really know that the people that are handling the product are certified. And that certification is offered by Washington Aggregates and Concrete Association. Bruce Chatton is one of the trainers. He's the ED and the trainer. And for example, I'm not going to give that training, but some of the key elements in that training, among others, is to really understand when the material is delivered to the site and you pick a handful of the material up in your hand and you kind of toss it up in your hand like a little bit of a softball. It's really important to really get a feel for what that paste wants to look like on the aggregate. It should have a slight sheen and not be too dull, too hot. It's probably a little past its prime. And you certainly don't want it completely breaking apart and being super shiny. And so getting a real feel for what the appropriate level of cure is of the material when it's delivered is really, really key. If you've got a bad batch, to recognize that before it goes into the job is key. And then there's a series of other processes for placement. But the way that we do verify the installation as we're moving along is by establishing a mix design, number 1, getting that mix design approved, and we offer some ranges of cementitious content, and then we require a submittal of the mix design, and that mix design has got a desired unit weight. So as the loads are arriving, we are assessing the materials, making sure the load tickets are conforming to our mix design, and then we're doing plastic unit weights of the fresh material to verify that what's in that truck is coming in close to our mix design, because if it's coming in too heavy, we're not going to get our voids, and if it's coming in too light, then we're probably not going to get the bond. And so to make sure that we've got a representative material. And then once we start our placement, we always start off with a test panel. We call it a test panel, sometimes we call it a reference panel, but we always require like a 225 square foot placement that's done right at the beginning, that the contractor really does their work and does their best job, and usually it's incorporated into the work. Sometimes it's not. The pictures I'm going to show you next happen to be from project I did in Bellingham 8 or 9 years ago, where it was one of the first times that a contractor in Bellingham had been required to get the NRMCA certification, and they wanted to do their test panel. And then we do that test panel, and we really use that as a visual guide throughout the rest of the process, because so much of the QA/QC is really on the aesthetics. And it's not just the aesthetics for the sake of the visuals, but there's a lot in how the material looks that will really tell us a lot about how it's working. So it's really there's a functional dimension to that. A uniformity of the surface, a lack of smeared paste. When the material goes in too sloppy, and it's too wet, we can very often get a lot of areas of smeared paste. And so we want to have a good agreement up front about what is the tolerable amount of paste smearing as a percentage of the surface and the size of any particular areas of smeared paste. Of course, we're checking for the usuals of thickness, but the uniformity can be the most subjective, but it can really get to the quality of the finish. And the uniformity of the surface is both in the kind of texture as well as any divots. So if the contractor is doing their power screed approach and they're really not, as they're running across with the screed, and they're not filling in those divots, and there's a couple of bellies, and that's what we want to catch that. Raveling, I think, is obvious. We sometimes will see that later. There's another hotly debated topic within pervious concrete around a test for raveling. And so the city of Seattle, for example, has a pressure wash test in their specification, where we take a pressure washer and we hold it at 3 inches and we gun the pavement, and we have an assessment of how many aggregate particles are liberated by that test. But that's a subjective test. I choose to use an aesthetic assessment of the reference panel, a good mix design, good unit weights as and that raveling is something that, if the other items that I can test objectively are in place, then the presumption is that the raveling will not be an issue, and that I do not personally use that in my specs. However, it's out there, and you may choose to use it in your specs, and it's certainly in the City of Seattle spec, but it can be problematic because of its somewhat subjective nature, but it's out there, and it's a test. The infiltration test, again, with the 1701, which we're going to demonstrate later, is another test. Some different jurisdictions and different designers have different views on that test as well. There's a concern, that's a performance test, and depending how your specification is written, one pitfall to avoid or to be aware of is if your specification gets very, very specific and prescriptive on the design side, and then also very rigid on the performance side, that can be problematic. So a specification approach that I like to encourage, offer ranges of acceptable characteristics for certain criteria, and then establish the performance, but not try and do both, because they sometimes can be in conflict. But you'll see out there specifications and requirements from various jurisdictions requiring a maybe 250 inches an hour or 100 inch per hour minimum performance on a 1701 test after construction. So have chosen personally to default to more of going with my unit weights and making sure that I've got the voids that I'm intending to have, and then if I've got that in place, then very often the infiltration test is not an issue. And then again, aesthetics, and that's really about visual conformance to the reference panel. Generally, can't pump pervious concrete, but we can conveyor belt. So telebelting can be done and is really successful. Generally, the process for actually getting the material from the truck into the pavement section is really about, the name of the game is not to handle the material too much. So crews that are really good at this will be having the chute and working the chute and really almost throwing the material into place almost at full depth, and then really coming by with the screed and just topping it off. We don't, maybe with an asphalt rake, to come and knock off the hills and valleys and then do a little screed. But really we want to minimize working it. So what we're seeing on the screen is one method. That's the Bunyan power screed. It's a placement method that I've seen work really, really successfully. By this weighted tube spinning at high speed, it's running along a form board on one end, and they got a piece of fire hose on the other end to reduce friction, using an asphalt rake there to kind of level the material out. And what I do have in my spec is a requirement for a certain number of pounds per lineal foot of that tube, because if you don't use high-speed spinning roller approach, you can often use a weighted roller as another approach to do a little bit of compaction. If the batch plant gets the mix design right and we use this placement method, it really goes pretty quick. It really finishes the material particularly nice. So then once we've got the material in place and finished, and that screed really, that power screed really does most of the finishing, then we want to put our joints in. And there's really two methods for doing that. One is rolled into the plastic concrete using a tool such as what is shown here, and that's my preferred method. It can come back certainly in saw cut joints, that's very common. However, then you have to deal with the slurry from the saw cutting, and you get a little contamination there, and I just prefer to see the joints rolled out with a purpose-built tool. And then lastly, cover, and leave the cover in place for at least 6 days and protect from contamination from surface run-on or any other contamination. Now, we are aware that there's a admixture out there that is being used by some, and I think it's kind of an emerging technology that claims to be able to avoid the need to cover pervious concrete. I haven't used it yet or seen it used, but it's out there. So I'm going to just show then a couple of projects of mine to kind of see what this material looks like in place. This is a project in Bellingham back in 2006, 12,000 square feet. We had about 2 inches an hour long-term measured in a silty sand, but we had nice infiltration rate. And this is an affordable housing project, so we were able to put down pervious concrete for less money than it would have cost to put in detention and treatment. And so we used, in Bellingham, we do have a really nice, poorly graded quarter-inch pea gravel material that makes a really nice pavement. And so we were able to, like I said, build this pervious concrete for less money than the traditional. It's kind of hard to see too much detail from there. But the movie that you saw with the Bunyan power screed was the test panel for this project. A couple of interesting notes all the way down at the far end in that photo. You see we have a little bit of a slope. Didn't end up putting check dams in that slope. And then we've got the parking lot kind of flattens out at the end. But we did have a concern. There's a neighboring house actually fairly close to the end of that parking lot. I did put one subsurface overflow in at the very, very end. So at the very end of the parking lot as a backstop on the whole situation, I put a flush curb, full depth, all the way across the back of the pavement between the end of the pavement and that house, set a slotted pipe down, outlet controlled, that outlet to the storm system and I set that invert of that overflow, as you remember from that detail, such that if the level of in the storage reservoir got basically to just shy of the bottom of the concrete, that it would overflow. And then that gave this neighbor peace of mind that we were not going to basically flood them out, which was their concern. This is another project, different scale. This is down in Vancouver, Washington, the Firstenberg Community Center. So this was a 110,000 square foot pour. We got about 4 inches an hour long term. It was a really nice outwash deposit over top of some cobbles, which we actually had at depth. We had 300 or 400 inches an hour, but luckily up near the surface we had about 4 inches an hour. This was before NRMCA certification, so we had quite a lengthy specification process. This is the project I mentioned that did well in the snowfall, in shedding water and not icing up when they did have a big snow down there a few years ago. But we were able to do this project with no curbs and really, I think, integrate into the preserved trees. That was the goal of Parks Department. This is a project where I basically went one step too far in hindsight on limiting curbs. I had had this ethic going into this project that we are going to do this project. I wanted no catch basins and no curbs. I was going to see if I could really achieve on this project. I didn't want any curbs. Turns out we had to go back and put in some curbs, particularly on some of those inside radiuses in the parking lot. We had quite a few people taking the shortcut through the landscaping than I had anticipated, which then caused a clogging problem. And so I guess this was to say we were able to do it mostly without curbs, but curbs do have a role with the general public in keeping them inside the lines and not tracking landscaping materials all over our parking lot. This is another one where we posed tremendous construction challenges. This is one of my first really pervious projects, and the staging ended up being a huge issue. I would do the erosion plan and the staging plan a lot differently for this project today than I did 10 years ago. The city wanted to demonstrate both bioretention and permeable pavement here, and what I did is we kind of interspersed bioretention and permeable pavement throughout. And I think what I would do today on this design is I would concentrate traditional solid asphalt all up around in front of the building with bioretention, and then I would have permeable pavement out on the distal parts of the site, because that would allow the contractor to come in, lay down some solid ATB, have a nice solid working platform. They had set up cranes up here to do the steel erection, and that really would have been the way to go. And instead, we did chase the mud and did a lot of remedy procedures on the subgrade and some remedial infiltration trenches that we had to dig in to account for some failed subgrade. Fortunately, we had about 6 or 8 feet of this kind of loamy sand material that was ideal for infiltration, and then we had all the infiltration in the world we'd ever wanted was about 8 feet down. And so in places, we did just access that 300 inch an hour material where we needed, so we knew we were going to be covered hydraulically.